Okay, here is your calendar for today. On page 114 in your ISN, you can just title it 5th 6 weeks. You're going to cut your calendar and place it on 115 and 116, and then today's lesson is going on 117. All right, so today we're going to look at sum and difference identities. These are on your reference sheet that I gave you. I have some of them up here as well. So we've got sum of angles and difference of angles. So you can see you have sine of a plus b, or cosine of a plus b, or tangent of a plus b, and then these are all the differences. Okay, and this is how they would work out because it's not a distribution. You're not multiplying sine times a and sine times b because this does not imply multiplication. So this is how the identities work out. So we're going to start by condensing some. So when I look at number 1, tangent of 5 pi over 18, not something that you know, maybe something you could figure out. But when I have this, I can't like factor out a tangent and then subtract those two or anything like that. But if I look up here at my identities, this one, it looks very similar to this. However, the signs are in a different place. So if I look over here, we've got tangent minus tangent over 1 plus tangent times tangent. And this would be the A and the B, the A and the B. So it looks like this right here, which means it's equal to the tangent of A minus B. So this would be equal to tangent of 5 pi over 18 minus pi over 36. Okay? So then I just need to literally subtract on the inside there. So when I do this, I'm going to need a common denominator, which would be 36. So this would be 10 pi over 36 minus pi. It's going to give me tangent of 9 pi over 36, which is the tangent of pi fourths, which is 1. All right, so then I have sine times cosine minus cosine times sine. So if there's a sine and a cosine, that means it's going to be one of the sine ones up here. And the addition is the sum, the subtraction is the difference. So make sure everything matches. So this would be the sine of A times the cosine of B minus the cosine of A times the sine of B. So I think it matches this one right here. So this will equal the sine of A, which is 13 pi over 10, minus B, which is 2 pi over 15. Okay, so to subtract those, I need a common denominator. I think that will be 30, so this will be the sine of 39 pi over 30 minus 4 pi over 30, which is going to give me the sine of 35 pi over 30, which would reduce to the sine of 5 pi over 6. No, it does not. That would be 7 pi over 6. Okay, 7 pi over 6. Sorry about that. All right, so sine of 7 pi over 6. 7 pi over 6 is in the third quadrant. Sine is negative there. The sine of a pi sixth angle, 1/2. So it's negative 1/2. All right, let's look at number 3. We've got the tangent. So this is a tangent one. Look back up here. So I'm adding in the numerator, so it should be this one. But again, make sure that like this is A, B, it's 1 minus. So I believe it is this one. So this will be the tangent of 48 plus 102. So that is the tangent of 150. Okay, but we think in terms of radians. So I want to know what this is in radians. Well, 150 is 30 less than 180. A 30-degree angle is pi 6, so I'm pi 6 less than 180, which would be 6 pi 6. So this will be tangent of 5 pi 6. This is in the second quadrant. Tangent is negative in the second quadrant, and the denominator is a 6. It's square root of 3 over 3. There is my answer. All right, so I have cosine times cosine and sine times sine. So cosine times cosine, sine times sine, cosine times cosine, sine times sine. This is minus, but it's not a difference one. It's an addition one. It matches this one right here. So this is going to be the cosine of A plus B. This is the cosine of 300 plus 15, which is the cosine of 315. Okay, so again, I want to think in terms of radians. So 315 is 45 before I get to 360. So if I take the 2 pi and back up 45, which is pi fourths, that's going to give me the cosine of 7 pi fourths. And cosine is positive in the fourth quadrant, and that would be square root of 2 over 2. And there you go. Okay, so now I'm going to simplify the expressions where we don't have, we're not just going to get actual values, we're going to get the expressions in the end. So if I have, so now you need to be looking up there or looking at your reference chart, and I have the cosine times cosine plus sine times sine. So cosine times cosine and sine times sine, that's going to be a sum or difference of a cosine. And since this is addition, it's going to be the difference for cosine, so this is going to equal cosine of a minus b, so that's 2x minus 4x, which is equal to the cosine of negative 2x. But I don't get to leave a negative argument in there. So when I look back at my reference chart, the cosine of negative theta is equal to cosine of theta, so this is cosine of 2x. Okay. Now, look at number 6. This is going to be a tangent. So I make sure that the A-B thing matches. And since this is addition and this is subtraction, it matches the sum of the tangents. So this is going to be equal to the tangent of 4 theta plus theta. So when I add those two together, I just get tangent of 5 theta, and that's it. All right, sine times cosine and cosine times sine, that's going to be a sum or difference of a sine angle. And since it's sine and this is minus, it's the difference. So this will be the sine of a minus b. So this is going to be pi halves minus alpha. And then sine halves minus alpha, if I look at my reference chart, that is equal to cosine alpha. All right, so I've got tangent, and I've got tangent minus tangent, and then this is 1 plus, so this matches the difference of angles, and my ABs work out right, so this is going to be the tangent of A, which is y, minus B, which is pi halves. Now, that does not match my reference chart, because on the reference charts, it's pi halves minus theta, not theta minus pi halves. So remember how we flip this around? This is going to be the tangent of negative pi halves minus y. All right, so this is like tangent of negative theta. So I look, and the tangent of negative theta is equal to negative tangent of theta, which is pi halves minus y. So now that I have that, tangent of pi halves minus y equals cotangent. Can't forget about that negative there. So this is going to equal negative cotangent y. Okay, now remember, don't just be blindly writing this stuff down. You need to be looking at your reference chart, finding this stuff on there, actively using it. All right, flip this over. So now we are going to prove the identities using some of this new stuff we just looked at. So I've got the tangent of x plus pi fourths. I want to prove that that equals tangent of x plus 1 over 1 minus tangent of x. So I think I would rather work with this side because I know what I can substitute in for that. That's not going to equal cotangent because this is not pi halves. So this is going to be my goal. This is what I'm going to work with. All right, so the tangent of a plus b is going to be equal to the tangent of x plus the tangent of pi fourths over 1 minus the tangent of x times the tangent of pi fourths. Then that has to equal this right-hand side right here, tangent of x plus 1 over 1 minus tangent of x. Okay, so then look at this over here. Well, tangent of x plus, well, tangent of pi fourths is 1. So this is going to be tangent of x plus 1 over 1 minus, so tangent of x times tangent of pi fourths. Tangent of pi fourths is 1. So when I multiply that, I just get tangent x. And then look at that, we're done. That equals tangent of x plus 1 over 1 minus tangent of x. And it works. Okay, so number 10. I want to prove this. Now, I do realize you can find this exact thing on your reference chart. However, just substituting cosecant theta here doesn't prove anything. So in order for me to prove this identity, I can't use this identity in it, when that's specifically what I'm trying to prove. So this is going to be my goal. I'm going to have to instead figure out what I can do with this. Now, your sum and difference identities you have for sine and cosine. You don't have one for secant. But this is like secant of an angle that's equal to 1 over cosine of that same angle, which is pi halves minus theta. So still, I know that cosine of pi halves minus theta is equal to sine, but I can't substitute that in because I can't use an identity from the cofunctions to prove a cofunction identity. So instead, I'm going to use the sum and difference part here. So this is cosecant theta equals 1 over. So cosine of a minus b will be cosine of pi halves times cosine of theta plus sine of pi halves times sine of theta. It's 1 over all of that. So I'm going to keep going. Cosecant theta equals 1 over. All right, so cosine of pi halves. What is the cosine of pi halves? It's 0. So 0 times the cosine of theta is 0. Plus, so they don't even have a first term anymore, sine of pi halves. Sine of pi halves is 1. 1 times sine of theta is sine theta. Then that means that cosecant theta equals cosecant theta. And this is the proof of why these cofunctions work. All right, number 11. Got the sine of x plus y. Okay, there's lots of stuff going on here. And that's all equal to tangent y. Left side definitely looks more complicated, so I'm going to make this my goal. So my sine of a plus b, using the identity from my reference chart of the sum of the angles, this becomes sine of x cosine y plus cosine x sine y. Minus, then I have to do sine, and this is a difference. Now, I'm subtracting something with more than one term. I need parentheses. This is going to be sine x cosine y minus cosine x sine y. Close my parentheses. All over, then in the denominator, cosine of a plus b is going to be cosine x cosine y minus sine x sine y plus, and since I'm adding more than one term, I don't have to worry about parentheses, do cosine of the difference of a minus b is going to give me cosine x cosine y plus sine x sine y. And that all equals tangent y. Okay, so take a minute, let all that sink in, understand where this came from, okay? Because this all came from the sum and difference identities. So now I'm going to simplify things. I've got sine of x times the cosine of y minus the sine of x times the cosine of y. So these two cancel each other out. Then I have cosine x sine y minus a negative cosine x sine y, which actually becomes plus a positive, so this is 2 cosine x sine y in the numerator over, so I have cosine x cosine y plus cosine x cosine y. So it's going to be 2 cosine x cosine y, and then negative sine x sine y plus sine x sine y, so those two cancel each other out, and that has to equal tangent y. So then the 2's cancel out, the cosines cancel out, that leaves me with sine y over cosine y equals tangent y, and that means that tangent y equals tangent y. And there you go. Okay, number 12. I'm going to warn you before we get into this that you need to write small, because I should have made your box a little bit bigger. Okay, so cosine theta minus 4 sine theta equals cosine 3 theta over sine theta cosine theta. So which side looks more complicated is totally a matter of opinion. I think that, sometimes we don't make the best decisions, and when you jump in, if you start working with the left-hand side and you feel like I really don't, it's not taking me anywhere, then might want to, rethink that and go back and look at working with the other side. So we are going to work with the right-hand side, which means this is my goal here. So cosecant theta minus 4 sine theta. Okay, so here's the thing. Sine times cosine in the denominator, that doesn't give me anything. Cosine of 3 theta, even if you look at your reference chart, so go look at your reference chart. Do you see a cosine of 3 theta anywhere? You should see that you have double angle identities right about here. So here are your double angle identities. And so we do have like a cosine of 2 theta, but there's no 3 thetas, right? And we haven't talked about these yet anyway, but I will tell you I did things in a little bit of a different order last year, and I forgot to change one of the problems. So even though we haven't looked at the double angle identities yet, we are going to end up using one, but not right this second because we don't have a double angle. But we are going to have to use this on this assignment because of some things I changed. Okay, so let's go back over here. So I don't have a triple angle identity, but I do have a double angle identity. So, and I also need to be able to substitute something in somewhere. I can split things apart, just like we can split fractions apart. I can actually make cosine of 3 theta into cosine of theta plus 2 theta over sine theta cosine theta. So what I have now is I actually have cosine of A plus B. So I kind of forced it into that, which is something we have to decide to do sometimes. So cosecant theta times, minus 4 sine theta equals, so cosine of A plus B. And so when I find that on my chart, that is going to give me the cosine of A, so that's cosine theta times cosine 2 theta minus sine theta times sine 2 theta, all over sine theta cosine theta. So rewrite the left-hand side. Cosecant theta minus 4 sine theta. All right, so on the right-hand side, can I cancel anything out? Like, can I cancel these cosines out? The answer to that is no, because I have 2 terms up here. Unless I can factor out a GCF and then cancel, but there's no GCF to cancel out. So instead, I'm going to have to see what else I can substitute. Like for sine and cosine, not really much I can substitute, but the double angles, the 2 thetas, which again, I know we haven't talked about double angles, but they're on the reference chart. I think you can substitute things. Here's the deal with cosine 2 theta. Find cosine 2 theta on your double angles and look at it. Don't just stare up here because I'm not going to put it up here because I'm going to make you look at this. You have how many choices? I got 3 choices, right? 3 choices of what I can decide to substitute in. And we could decide on any of them. But let's think about this. If I do, so I have that first one, which is cosine of 2 theta equals cosine squared theta minus sine squared theta. Well, that's not plus, so it's not just 1. If I substituted this in right here, I'm going to have to distribute this cosine. So if I have a cosine squared and then I distribute a cosine, it's going to give me cosine cubed. Probably doesn't want to be something that I want to deal with. So I think I would like to avoid substituting any cosines if possible. Now, no matter which of the 3 I substitute in, I will still get to the same right answer. It just changes some steps, but it's just, you just got to pick something. But I think because I don't really want a cosine cubed, I'm going to make this cosine theta. So for cosine 2 theta, I'm going to substitute the second one, which is 1 minus 2 sine squared theta. And then minus this sine theta. Then I look for sine of 2 theta. So that double angle, I only have one option, and that is 2 sine theta cosine theta. And then all of that is over sine theta cosine theta. Okay, so now I think I'm just going to distribute. So this is going to give me, on the left, cosecant theta minus 4 sine theta equals. So I'm going to distribute here. This is going to give me cosine theta minus 2 sine squared theta cosine theta minus 2 sine squared theta cosine theta. Oh, I don't need a parenthesis there. All over sine theta cosine theta. All right, so now I'm going to come back up here, rewrite my left-hand side. Cosecant theta minus 4 sine theta equals. So in the numerator, I have cosine theta minus 4 sine squared theta cosine theta. All over sine theta cosine theta. So in the numerator, I can factor out a GCF. So this is going to give me cosecant theta minus 4 sine theta equals cosine theta times 1 minus 4 sine squared theta over sine theta cosine theta. So now that I've factored out a GCF and these two things are being multiplied, I can knock those out. That's nice. So that leaves me with cosecant theta minus 4 sine theta equals 1 minus 4 sine squared theta over sine theta. All right, so this is 1 minus 4 sine squared theta. It's not just 1 minus sine squared theta, so I can't just like substitute in a sine squared. However, this is, it is a difference of squares. I could factor that into 1 plus 2 sine theta times 1 minus 2 sine theta, but that's not necessarily going to help me there, but I think I can split this fraction. So cosecant theta minus 4 sine theta equals, so I'm going to make that 1 over sine theta minus 4 sine squared theta over sine theta. So that leaves me with cosecant theta minus 4 sine theta equals, well, 1 over sine theta is cosecant theta, and then minus 4 sine squared theta over sine theta. That knocks one of those out, and I get 4 sine theta. And there you go. We are done. If you can't read your own work and you can't write neatly and keep up with what you're doing, that will be impossible for you. It looks way worse than it is, but you got to understand your algebra. I mean, that's the bottom line.